you have some choices. Choice number 1 is take the little x and multiply it through. I would not do that first, so let's not do that. Choice number 2 is multiply 14 times 8.5, 14 times 2. So let's do that first. So I'm going to make a little equation down here. I'm going to put in parentheses. I'm going to close the parentheses and open a new one and put the x in there to remind me I still have to multiply by x on the end. Okay? So 14 times 8.5, what's that, 119? Okay. So 119, oopsies, that goes inside parentheses. Okay. And then 14 times 2 is 28. That's going to have an x. And watch your signs. So good? All right. So now we have to do this again with the 2 here and here and here and here. Okay, so take a moment. You do it. Distribute the 2. And after you get that, combine your like terms and then multiply through by x. Distribute the second time. Whoopsies. We're going to subtract 2 times 18, that's 17x. And then I have to subtract a negative 4x squared. But when I subtract a negative, that becomes positive. So it's plus 4x squared. I've now expanded my 2 binomials to get this polynomial. I'm going to combine like terms. We're going to do 2 steps at 1. Make that 45. Okay, so far so good. Last but not least, I'm going to do a little Control A, Control C. Come down here. Control V. Get rid of all my parentheses. Oh, it's pink. Cute. All right. And now everything gets booted up by 1 degree. So that 2 is now a 3. That x to the first power is now squared. And 119 is now x. And I don't need the parentheses anymore. Now, I need to answer the question. Identify the degree. Well, my first term has a degree 1. Is my whole thing 1 then? No. Remember, your leading term is not necessarily your first term. That will determine my degree. So my leading term is right there. So leading term is 4x to the third. If I'm in a text box, I go up to the top menu bar, change it into equation editor, 4x cubed. And my degree of the entire polynomial is the highest exponent that you see. In this case, 3. Okay. So far, so good. Okay. So now let's take a look at the second part. It says, without graphing, figure out the vertical and horizontal intercepts. So I'm just going to make a text box down here. I'm going to write the word vertical first because that one's a little easier. Okay? Vertical. Right. So where is it crossing the y-axis? Dears? I'll give you a hint. Look at the polynomial. What's common to everything? What's the only thing in all 3 terms? X. Okay. So when it crosses the y-axis, x is equal to. So if all my x's are 0, and no matter what kind of fancy arithmetic I do, what am I going to get? 0. Okay. So my vertical is crossing at 0. Okay? So anytime you have something in factored form and one of your factors is just plain old x, it's crossing not just at 0. What do we call that point? The origin. Okay? So it's going to pass through the origin. We did a couple of these when we're graphing. All right, that's my vertical. Horizontal, a little bit more work. Okay? I'm going to give you a couple more minutes. It's going to take a little bit more work. And I don't want you to look at the thing we just created. Look at factored form, because that's what we've done before. So look at your factored form in the original. So right up here, I got 3 factors. That should help you figure out how many horizontal intercepts I got. You take the 3 things I highlighted, my 3 factors, and set them equal to 0. So I should have 3 zeros. Okay? You won't always have 3 zeros in a cubic, but in this particular case you do, because we have 3 factors. However many factors you have will be the number of zeros you have. I don't know. That might be something you want to write down. Okay? So your horizontal. So we have 14 minus 2x equals 0. I got 8.5 minus 2x equals 0. And the last one is the one that always messes with people because it's just too easy. What's my last factor? Just x. What's it equal to? So that's one of my zeros. That's one of my horizontal. So I'm not going to go through all the arithmetic, but basically 14 minus 2x is 2 times what is 14? That's 7. What times 8.5? Oh, no, you mean I have a decimal answer with hundreds place? Yeah, it's not that hard. 4 1/4. And the last one's the easiest one, but it's the one where people miss most often. Okay? One more time. Number of factors you have is the number of horizontal intercepts you have. All right, so let's prove all this. Let's just take a peek. So let's do my 119. Let's just take this thing up here. Well, we'll take it after we did. So ready? Control A, Control C. Go to Desmos. Control V. And then what was it? So was it 14 minus 2x? Why am I doing this? This is one way I could do what? I'm checking my work. Okay, so that green should turn purple. Okay, so when you expand a polynomial from factored form into standard form, Desmos won't help you with the algebra, but it'll tell you if it's right or not simply by the graph not changing. So if the graph doesn't change, where it just changes colors, then you're in good shape. Okay, questions so far? Okay, scroll down. We're pretty good at distributing. Y'all tell me. Anybody really think they need some extra help with that? Ask now or forever hold your peace. All right, sister, bless them. A little faster, sister. Come on. There we go. All right. So we're going to go 6-4. So we're going to spot the differences. So using graphing technology, so let's go back to Desmos. We're going to put f of x equals. And yeah, wouldn't it be nice if I could just go select that, but you can't. It's just the way the PDF is. It's more like a photograph than a text. So you're going to have to type it in. So go to Desmos. I'm going to turn off these ones. I'm going to type f of x in here. Equals x minus 3. What's the next one? X plus 7. X minus 2. The other one's x plus 7? Okay. But is x minus 3 in there somewhere? Yeah. Okay. So you know what? Commutative property says I can do these anywhere I want. X plus 3. Thank you. Okay. So x plus 3, x minus 2, x plus 7, minus 7. Okay. And then they said, hey, maybe you should go from negative 10 to 10 and from negative 100 to 100. So go up here. Y-axis, doesn't have to be perfect, but negative 10 to 10, negative 100 to 100. X-axis, negative 10 to 10. Y-axis, negative 100 to 100. And you should see that big old N-ish type figure. And then we're going to put G in. Now notice, G doesn't look a whole lot different. So can I duplicate a function? Am I able to do that? Remember how to do that? Have I shown you how to do that? I think I have. So activate the f of x anywhere in there. Go up to the settings icon. And there it is. Copy. So we want to change the color, and we're changing from F to G. So let's change the color to anything but whatever your default color is. I'm going to go to blue.
How do you change it?
Click and hold. Change that to G. And you have one itty-bitty thing that's different. What goes in front of the first factor? 1/2. Okay. Is a half a factor? Yeah, so I misstated myself before. Okay, so we have 4 factors, but we only have 3 zeros. So I should have said the number of factors with variables in them. So this first factor does not affect zeros. What is it affecting? Don't say it. Discuss with your group and then type it in. Okay. What does the 1/2 do? And what does it not do? What does not change? The x intercepts. So all three intercepts are the same. So remember what I said? The 1/2, any numerical factor is not going to change where my intercepts are. What does it change? It changes the y-intercept and pretty much every y. Think of it this way. It squishes it. Now, technically, we will use the phrase shrinks it. So here was my original in red. Easiest point to look at is my y-intercept. So it was 42, and this is 21, because half of 42 is 21, and half of every other point. So if I'm down here at my bottom and my top here, half of negative 48 is negative 24. It's rounding off just slightly. Okay. What's half of 0? That's why those numbers don't change. All right. So we talked about it. We described how they're the same and how they're different. What degree are these polynomials? Okay, so take these and rewrite them. So I'm going to make you distribute at least 1, 2 times. Well, in this case, probably like. Why do you have to distribute 10 times? Because I only got 3 things there. Why would that take 10 times? How many times am I really going to have to do this? Twice. So look. Oh, wait, that's too far. Uh-oh, messed up. Okay, so multiply these 4. Get your polynomial, and then you have to multiply again. So 4 times that time. So I said you had to do it a total of 10. So if it's 4 times the first time, how many are you going to have to do it the second time? What's 4 plus 4? 8. I said it has to be 10. 4. So you're going to have to distribute once. So take the first 2 and distribute them. Get your polynomial. It should be a trinomial. And then multiply by x minus 7. I'm not going to ask you to do it for all of these. Just do it for the first one. Okay, just do it for f of x. So expand it into standard notation. We're going to take our time with this because we have to do 10 of these. Anytime you make one mistake, it'll mess up everything else. So x minus 2 times x plus 3. Okay. I'm just going to do it down here even though we have space. Okay. So x squared. Oopsies. Parentheses x squared. So x times 3 is 3x minus 2x means it's minus x. Negative 2 times 3 is minus 6. And I still have the other piece, which is x minus 7. Okay? Questions so far? Good. Oh, it's plus x. Thank you. So 3 minus 2 is positive 1, not negative. And now I have to do 6 more multiplications. I got x times x squared, x squared times 7. I'm just going to kind of continue over here. X squared times x is x cubed. And then x squared times 7 is minus 7x. And then I'm going to go blue. So x times x is x squared. I said I was going to go blue. I guess I lied. And x times 7. So I said squared, but I didn't put it there. So that's squared. And then I'm going to line up my like terms. So I'm going to make a new equation box down here. So x squared times x. X times x squared is x squared. And then x times 7 is minus 7x. Okay. And then I'm just going to line these up and make it a little prettier. And I got one more multiplication, a third one. Let's go green. So 6 times x and 6 times 7. So 6 times x is minus 6x. -6 times -7 is plus 42. I'm going to use my shapes tool. I'm going to make this nice horizontal line. Line everything up. Put my answer down here. If it'll let me. Come on now. There we go. Come on. There we go. X cubed. -7 plus 1 is -6x squared. -6 minus 7 is -13x. And then plus 42. And if I did this correctly, I'm going to do Control A, Control C, go back to Desmos. And if I did it properly, what should happen to my graph? Just changes colors. Look at that. It went from red to pink. If it doesn't match up, then go back and redo stuff until you find your mistake. Questions? Okay, let's answer the question here. Make a text box. 3 equals 3 because our largest exponent is 3. So far, so good. Move on. All right. So now we're going to make h of x equal this. So go back to Desmos. Sure. I'll pause for a moment. What is going on? So use graphing technology to check your prediction. What do you think is going on here? So we've already kind of done the graph part. Got a little Florida, Miami heat colors going on. I know. I'll fix it. She's always keeping me in check. Okay. So what is going on from one graph to the other? Make a statement. Write a little text box. I don't know. You might have to pinch this a little bit and go a little higher and a little lower than 100, -100 to get a really good idea of what's going on. And then I will show you the easiest way to figure this out, which will help you with the cool down. How are we doing? So I'm going to duplicate it. I'm going to change my H to a, I don't know, K. It doesn't like I. I'll explain why in a little bit. And let's change my color just in case I make a boo-boo. I'll see it. All right. Take a look at your first factor. I have a 3 and I have a 6. Do they have something in common?
Yeah.
So that would be called a common factor. What is my common factor of 3 and 6? 3. So I could rewrite this. I factor out a 3. And there you go. So K is the same, or H or K is the same as F, except every Y value is triple. Okay? So what we say, remember I said the other one is shrunk. This one is stretched. So it's stretched by a factor of 3. Okay, so text box, stretched. It's nice when they actually use words that we can understand, even if I can't spell them right. Stretched, stretched by a factor of 3. In other words, every Y value on the same X value is 3 times as tall. Because look, what did I factor out? I factored out a 3. Okay. To go to an arbitrary point on either graph is hard. Where do you think you should look to find out if you couldn't factor it out easily? The y-intercepts. Because that's going to be the easiest place to look. Because what's your x value? 0. Doesn't that make it easier? So what's 3 times 42? 126. Look at that. Okay? So if you focus your attention on the y-axis, it's going to make this easier to do. All right. So that's not the cool down. That's going to be later. Hey, look at this one. What did I just say? Pay attention to the y. So why do these two graphs have different vertical intercepts but the same horizontal intercept? So look at the stuff we just did and then see if you can figure out what you can answer, how you can answer this question. And then what they're saying is, I'm doing something to the green one to make the blue one. Figure out what you have to do. What is the value of k to turn green into blue? So let's first start this one together. We've done a bunch of these already. So why do they have the same horizontal but different vertical intercepts? Or in this case, it's being shrunk. So we're not going to talk about the number yet. We're saying it's compressed or shrunk. Compressed by some unknown factor. It's your job to figure out what that factor is. Unknown factor. Now keep in mind, when I'm compressing, it means I'm making the number smaller, but I'm multiplying. What kind of numbers would I have to multiply to make it smaller? A fraction or decimal. So you're going to have to find the value of k that makes this smaller. So I've got to do that. We focus our attention just on the y-intercepts. I see a -1 and I see a -5. Remember, we're going from green to blue. So in essence, what I'm asking you to do, and this is an easy one. At some point, you're going to have to do what I'm doing now. So if we're going from green to blue, it's k times my -5, or let's just say it is -5k, is equal to my other one, which is -1. Okay? So if I divide both sides by -5, what do I get? 1/5. Okay? So it is being shrunk by a factor or compressed by a factor of 1/5, because a negative divided by negative is positive. So my shrinking factor is 1/5.
Yeah.
All right, question. So let's summarize real quick. I'm going to give you some shortcuts to think about. When you are asked about the degree of a polynomial, all you need to do is focus on the exponents. Notice 3 of those little boxes don't have exponents, so the exponent is 1. And then I add 2 plus 1 plus 1 plus 1. What's 2 plus 1 plus 1? And that tells you what your degree. What did I not have to do to find my degree? Multiply it out. Because do you think the last one was hard? Now I got 4 things to multiply out. So that's a binomial times a binomial. That's a trinomial. Another trinomial. So that's 9. So you just did 4, 8. You have to do 17 multiplications. Okay? That's a lot. And if you're asked, what is the y-intercept? Again, you don't have to multiply the whole thing out. What is 3 times -3? -9 times -1. +9 times 2 is 18. And then I'm multiplying by 0.25. And if I do that, I get 4.5. Okay? Except that one should be plus 4.5. That's wrong. Okay. So I don't have to multiply everything out to find my vertical intercept either. Just multiply the numbers. So leading, add the exponents. To find the y-intercept, multiply the numbers.
Wait, does it matter the order in which you multiply
Nope.
numbers?
Nope.
Because you have the negatives.
Because so that should be positive. I'm not sure why they made a boo-boo. Because I have an even number of negatives. That should be positive. Unless there's... Nope, it was a -0.25. So, all right, last thing you need to do before you go. Okay, cool down. Cool down. When you're done to cool down, you're done.